review an idea that you should already know, which is just a little bit about inverse functions, not quite getting into how we find them or how we derive or integrate them, but just a little bit about them. So, along those lines are functions that are called one-to-one. And definition of a one-to-one function is, and this definition is a bit longer than the space I gave you, I apologize for that, is a function one-to-one if it never takes on the same y value twice. Meaning f of one value of x is never equal to f of another value. How can you determine if a function is a one-to-one function? First of all, to be a function, it has to pass the vertical line test, right? But to be one-to-one, it has to pass the vertical line test and the horizontal. Same thing as the vertical line test, only for the horizontal line. Does the horizontal line touch it at one point, no matter where we put that horizontal line? So, if you notice, this first example is going to be one-to-one. It does pass the vertical and horizontal line test. The second one is not one-to-one, because it would not pass the horizontal line test. Now, definition of an inverse function, if f is a one-to-one function with domain A and range B, then its inverse, f to the negative 1, has domain B and range A. The domain and range switch. So your x values become your y values, and your y values become your x values. How do we graph an inverse function? Well, a couple ways to think about it. We can think about it as reflecting over the line y equals x. Or we can think about it being the x and y coordinates switched. So I lots of times think about it in terms of the second bullet point, the x and y coordinates are switched, but check it with the first bullet point. So if I have y equals 2x plus 3, or 3x plus 2, y-intercept of 2, slope of 3, this is my line. Now, if I take these points that I've plotted and flip them, for example, I've got this point 0, 2. On the inverse, it would be 2, 0. I've got this point -1, -1. On the inverse, it would be -1, -1. I have the point 1, 5. On the inverse, it would be 5, 1. And -2, -4 become -4, -2. So my inverse is in blue. Now, does it appear to reflect across that line? Yeah, it does. So the reflection point is a good way to check. Looks like it's reflected. Let's try another. X squared minus 1 from 0 to 3. So x squared minus 1 from 0 to 3 would look like this. And it goes on. 3 would be at 8, which our graph doesn't go that high, but that's what we've got so far. Now, let's graph the inverse. Let's do that in blue again. 0, -1 becomes -1, 0. 1, 0 becomes 0, 1. And 2, 3 becomes 3, 2. So I end up with a line that looks like this. And again, check the idea of reflecting over the line y equals x. Does it appear to reflect over that line? Yes. That's an inverse. Hopefully you remember a lot of this. The homework will question you a little more about it, but it should be stuff that you know. If you have questions, read the class tomorrow.